Welcome back to Dr. Read the Puddle. For all of you that subscribe to my channel, I want to say thank you for spending your time watching my videos. I figured after the last video on cast aluminum repair, it's time for some redemption and actually show you something educational. So today's lesson, we're going to go over the proper way of switching out a spool of wire. My past 19 or so years teaching welding, I have learned that a very simple procedure can have lots of little mistakes made and will cause you major problems in your weld. You can have the contact tips burning back, you can have bird's nest at your wire feeder. There's a lot of problems that can be caused by improperly switching out your wire. So we're going to go through the complete setup, and I'm going to give you some, well, without stepping on the godfather of social media's toes and saying tips and tricks, I will say pointers and suggestions to get you back welding right away. So what you'll need for today's lesson is a new spool of wire, some preferably Bounty paper towels, and I will explain why shortly, your welpers or wire cutters, something to clip the wire. Always start with a new contact tip. And one of these little spring clamps you would get at Office Max or Walmart, something to clamp on that paper towel, and I will explain. So give me a second, I'm going to zoom in on the wire feeder and we'll get going. Okay, as you can see, there's only a couple strands of wire left on this spool. So we're going to go ahead and sacrifice it and go ahead and cut your wire right there and just let it go. We're not going to use it, it's scrap. To remove the spool, obviously there's a couple ways. We can take this nut off and literally disassemble the entire braking mechanism, and that still won't allow the plastic spool to come off. Or we can use these nice little spring clamps and just pop that spool right off. Okay. Now, you will notice I left a very small amount of wire hanging out of the liner, and there's a reason for that, and I will show you that in a few minutes. So what we want to do is pop open your wire feeder to allow that wire to slide through freely. Now, while you have this machine at this stage, it's a good time to get an air gun and blow out some of the dust and even wipe off some of the dust that accumulates inside the machine to keep your equipment looking nice and keep it working properly. So now, as you remember, we left a little bit of wire sticking out of the drive rollers. Now, there's a reason for that. Before we put that new spool on, we want to do a very quick check on our liner condition. Over years of using your MIG gun, the liner can get stepped on, you can drop steel on it, you can put a very sharp kink in it, which will actually put a bend in the liner, and that will not allow that wire to flow through that liner freely. So a very quick pointer in checking that liner is leave that wire hanging out the drive rolls, and that wire should slide through that liner very smooth. If you have to tug on that wire, you've got a kinked or damaged liner, and it's time to either try to clean it if you can, or you can also just replace it, and they're not too expensive. Between probably $25 and $30, you can get a brand new liner. But you can pull out that excessive wire and just make sure it slides through the liner freely, and that gives you a very quick and cheap down and dirty check of that liner to see if it needs repair. Now, we're wasting about 12 to 15 to 20 feet of this wire. Now, this is an ER70S6 035 wire. So if you really want to save some money on your TIG filler wire and you're TIG welding very thin material, you can save these little bits and TIG weld sheet metal or something very thin. So a little pointer to save you some money. I usually don't deal with it. Most of the time it ends up in the scrap room. So we are about ready to change out our spool, so I'm going to relocate the camera and we'll be ready to rock. Okay, back to our Miller-Matic 252. So before we do anything, it's a very good time now to check our drive rollers. I would say that, over 2 or 3 spools of wire, you are going to end up with some residual graphite or drawing lube when they manufacture the wire. We do check these here at my college, so almost every spool we change them. But if you haven't done that for a while, I would say, take them to the sink, use some dish soap, some lacquer thinner, some denatured alcohol, anything like that, just to remove any of the residual graphite that may be on your drive rollers. These are pretty clean. You can see there's little to none on there, so we should be okay. So always remember that when you put your drive rollers back on, the diameter wire that you are using should be facing you. So this is 035 wire, so we want to make sure that that 035 is facing us so we get the right size drive rolls. And we'll make a little lesson on different types of drive rolls and what they're used for in the future. So, okay, before I put that spool on, I want to make sure that I feed the wire into the machine properly. So this one feeds over the top of the spool. You can see the angle. That wire comes off the top. Some of these drive roll systems will be turned flat or pointed down a little bit. That means it spools off the bottom of the wire. That's very important because we did have a situation in the past in my college here where a student put it on the wrong way and the wire actually cut through the guide tube. It sawed right through it after 33 pounds of wire over months of use. It actually cut through the drive roller into the aluminum casting here, so we had to replace the whole casting. So those things do happen. So, okay, you can see there's a locator pin on there. On the spool, there will be a hole to locate your wire on, so make sure those line up, kind of important. And I do have it set up to feed off the top. So that goes on like that. You can see that wire feeds off there, and always remember to put your lock back on so the wire doesn't fall off in use. Kind of an important step there. So we want to take the pigtail, pull out a little bit of straight wire, and just clip that pigtail off. That pigtail, obviously, don't try to straighten it to save 4 or 5 inches of wire. So we'll take that wire, slide it through the first guide tube, down into the liner, and sometimes it goes right in there like you can see. And we will back off this wire tensioner all the way just to show you how to properly adjust that wire. So I'm going to close that tensioner on that drive roller, and we're basically all set up here. Now, you were probably wondering, why Bounty paper towels? Well, your shop is dirty. You're grinding, you're welding, there's smoke, there could be humidity which causes slight surface rust. The Bounty paper towel does a very nice job of scrubbing that wire. So if you look at that wire, it has some black graphite on it from when they drew it through the dies to reduce the size of that wire. So that did a good job of keeping all of that out of my good liners. So I like to have these on pretty much all the machines whenever I can, because it's a good way of scrubbing your wire. So just take your Bounty paper towel, fold it a bunch of times, get it pretty small to where it's pretty thick so there's some tension on that wire. And then you can take your little clip you get from Office Max or Home Depot maybe, but probably Walmart or Office Max, and that allows you to scrub that wire. Now, a good quality wire should have very little scum on it to get stuck in the liner, but it's still a good way of keeping your wire clean. So we are ready to set the drive roll tension and to show you the braking mechanism. So I'm going to grab the gun and I'll be right back. Okay, we're ready to set our drive roll tension and our brake tension on the spool. So as I said before, I left the tensioner pretty loose. So when I squeeze this trigger, you will see that the drive rollers are going to slip and not pull that wire very well. So let's go ahead and squeeze the trigger and see what happens. So you can see there's basically no tension. Those wheels are just spinning there. So let's tighten down on that and get that spool to start spinning. So you can see now that the spool is spinning, but they're probably not tight enough. And how do I know? Well, what I usually do, take my hand and just grab that spool, and you can see with little to no pressure, I can make those rollers slip. So it's way too loose. So if you were welding on something and you accidentally kink this liner too much, a lot of times that'll stop that spool from spinning and it burns back your tip. And we don't want to burn back our tips if we can avoid it. So let's go ahead and tighten that down a little more. And we should be able to grab that spool and with a little bit of effort make those drive rollers slip. So we're still pretty loose there. So let's go a little bit more here. You can see we got some wire coming out now. Now that's getting pretty close, so it takes a little bit of effort to do it, to make those slip. So I'd say that's about perfect. Now, if your drive roll tension is so tight, it's literally pulling your arm down, you're damaging the wire. You're probably changing that round wire into an oval or squishing down, or you could even, if you tighten them too much, shave a little bit off of that wire. I've seen these little tiny bird's nests happen in the wire feeder system. So if it's so loose, you can take your pinky finger and make it slip. then it's too loose. So the proper tension is you should be able to make those drive rollers slip with a little bit of effort, but not too much. Now the braking mechanism, what does the braking mechanism do? Well, the braking mechanism is there so that wire does not freewheel. If you're running very, very high wire speeds and you're doing, 400, 500, 600 inches per minute, what can happen is you let off the trigger and the spool keeps spinning and it ends up unraveling inside here. And there's a situation where if that wire comes across and it arcs across your positive and your negative, it'll start glowing red and you'll actually have a burn issue inside. We have a couple machines where there's actually little burn marks from bird's nests that have happened and it actually melts into the stickers here down here. So it does happen, but if you keep that brake mechanism so that spool stops pretty instantaneously when you let off, that's where you want to be. If you let off the wire and it freewheels, tighten it a little bit more until that freewheeling of that spool stops. Then you're at the proper tension. It should stop almost immediately and not have any unraveled wire there. So that's the proper setup of the drive rolls and the brake mechanism. So let's get the tip put back on and we'll be all done. All right, we have a fresh 33 pounds of wire on our machine. We're ready to weld. Take your brand new contact tip. This is probably the easiest part of the whole job. Slide it over that wire. Take your wire cutters, cut off any excess. Take your nozzle, replace it, and you're ready to burn. So, thanks again for watching. If you liked this instructional video, please subscribe and I will do more. I think I will be working on cast and helix of wire next, and that's going to explain a little bit more of why you have some feed issues with your welding wire. So please hit subscribe and stay tuned for more videos. Thanks for watching.